Okay, so I have gone through this whole process of showing you like a really kind of simple, narrow example of exploring a bit of the data set, coming up with a few hypotheses, and I gave you, I kind of maybe seeded a few ideas, but those are just like a few ideas, man. Like there's a lot of other things you can do, right? So I don't want to create like 150 videos of all the different things you could do with the data set. I'll leave that up to you all to come up with those ideas and explore them and go down those rabbit holes, let's say. But there is a publication that I was involved with, which is one of my favorite papers that I've been a part of, that kind of gives a good overview of like the general techniques that you could apply to these data sets. So you can of course go to this link here, which is the actual article itself, or there's a link there where I've hosted this PDF quickly for everyone to see. And if we'll come over here to this the second link, where if you go to this link, you can see it and download it if you want to. This is a data science for building energy efficiency. It's this high level review of we took basically, and Mahmoud Abdulrahman is the student who he's not a PhD student anymore. He actually just recently graduated with his PhD successfully. And he did this process where he took the Elsevier, which is a big publisher in this field, 30,000 different papers, publications from this database, from Elsevier's database, that were retrieved through an API. And Mahmoud created this text mining process where he actually extracted really cool information from all of these papers to get this kind of like really interesting, comprehensive, very high level mind map of what's been done in the research domain, at least as applied to built environment data. And so maybe this gives you, I think this publication could give you kind of an idea of what the range of type of things that you could use, or the types of data and things like that. So I'm going to quickly go through this publication. Of course, you can read it on your own. He defines certain keywords like data science, energy efficiency, and phase. Those are the key dimensions of the analysis. Data is the different types of data between time series and metadata, spatial data, all the different types of data. Data science is defined as the techniques that you can apply: machine learning and clustering, unsupervised, supervised, optimization. You name it. There's a buzzword out there that you can leverage in that. And then energy efficiency, of course, is the actual end result or objective. So you might be looking at concepts like fault detection and system optimization and demand response. These are kind of these energy related topics. And then phase is related to the life cycle phases of the building industry: design, construction, operations, there's 5: design, commissioning, operation, maintenance, and retrofit. So the little bit about how he did this: 30,000 articles were extracted. He basically used text mining, which is a cool, interesting topic. Some of you might be thinking about using that. And there's a GitHub repository that's referenced in this paper that you can check out how he did all this stuff. He wanted to basically understand the relationships between data science that's used in different applications during certain phases of the life cycle of buildings. There's lots of paper, like these are the sources of the papers, of the 30,000 papers. Here's a nice visualization of the word to vec, which is converting text into vectors that can be used for clustering, which is what he did. A little bit more about how he did it. There's going to be these really cool visualizations, which I'm going to show in a second. This is a really cool vector representation of the words. I'm not going to dive into it. We don't have enough time, but if you want to stick your brain on there and try and figure out anyway, it's cool. It's kind of a clustering type visualization. Now we get into the things that I think are interesting, which are these kind of heat maps. And these heat maps show, in this case, data is the blue column here on the left, which is all the different types of data that you can maybe find and that he extracted from these papers. And then on the top, on the y-axis, if you tilt your head, you can read energy efficiency applications. So these are the type of applications that are there. I want to go to a better one here. Oh, sorry, we'll stop here. And this one as well. Data science, these are the data science techniques. And then on the left are the different data sources. And let me stop here for a second to look at the actual heat map itself. So if you zoom in here and look at this, Let's do that. Let's zoom in a bit. You can see basically this heat map has been sorted from top to bottom and right to left in terms of the most to least, in terms of the relationship of the amount of papers or the frequency that these words are mentioned in these 30,000 papers. And optimization, for example, data science, optimization, validation, energy simulation, regression. These are all data science concepts that are very, very popular. Down here at the bottom, you have dimensionality reduction, segmentation, generative adversarial networks, GANs, that are much less, common in the literature. Energy consumption, historical data, these are all kind of words that are very popular. So that's the way to use these maps, is to kind of get this overview of what's out there. And then Mahmoud does this really nice segmentation and clustering of these concepts. So he segments data science that he's extracted into these categories of optimization, statistics, deep learning, data science, machine learning, reinforcement learning, pre-processing, transfer learning. And then energy efficiency side, he clustered it according to the different phases. Down here, you have the different types of data between passive and heat recovery, energy consumption, airflow, whatever you have it. So really, this is kind of the breadth of the last 15, 20 years of 30,000 different papers. These are the different concepts that are there. Let's see here. There's one more visualization down here. That one's these are cool. I'm not going to spend time on them. Here, this is the one that I wanted to talk about, because this is really, these are a little bit more simple, but they're showing really the data science types of techniques. Let's see if I can get this out of the way. No, it's okay. Data science techniques used in energy efficiency applications. So here on the left, you can see these are the really common energy efficiency types of things that your team could look at. So you could use one of these, or like a convergence of these. Fault detection diagnostics. That's what I mentioned before. That's really popular. There's tons of literature out there. Retrofit analysis, how to find and target good buildings and determine how much energy they might save. Model predictive control, demand response, energy benchmarking, life cycle analysis, energy audit, UBEM. I'm not going to go through this whole list, but this is really these are the options that you have at your disposal possibly in your solution. So if you go back to the judging criteria, you'll notice that there are certain directions they want your team to head in, but they don't really tell you exactly what tools you have to use or you're supposed to use, right? So this is your toolkit essentially. The data, and this is your toolkit in terms of objectives. Here you have the toolkit down here in terms of general data science techniques, optimization, multi-objective optimization, regression, data, reinforcement learning. So this is kind of an interesting way to look at the range of possibilities you have. You might have certain expertise in one of these. That's maybe the direction you want to go in. Your team might have certain interests or expertise or whatever you have it that's really cool, and you want to play with it and try it. That's great. But this is a good way to kind of see what other options you have, or what, it's not super comfort. It's not completely exhaustive. There are sort of new things, especially there's a lot of really innovative ideas that you could think of, taking outside data sets and playing with them and using things like Google Trends, for example, which there's another paper that from my team that you can check out. And the rest of the paper, we got some examples, really good representative examples of a lot of these type of concepts. And then down here, last but not least, is the repository where you can learn about the text mining method that Mahmoud implemented. So I've probably overwhelmed the heck out of you in this video, because I've shown you that there's a bajillion different things you can do. But that's kind of my goal, in a sense, is to give you a sense of how wide and broad this possibly could be. And as long as you're driving towards those objectives, those high-level objectives that the judges are going to be looking for, that's really your kind of primary goal, in a sense. But what tools you use to get there are, the world is your oyster, right? So good luck. I mean, this is the last video. Hopefully these videos were helpful in getting you started. If you weren't familiar with APIs and all these things, and Python and Pandas and Seaborn and all these libraries, hopefully it was helpful. Good luck. I'm really excited to see what everyone comes up with in the competition. It's going to be really cool. Thanks a lot for listening, and good luck.